we have Chein, and he's going to be speaking on expanding the mind's workplace. Chein is a principal investigator at the Neurocognition Lab at Temple University in Philadelphia. His research has focused on the key role played by working memory, the mind's ability not just to remember, but to juggle facts and figures, what he calls the mind's workspace. He's published 2 studies which found that people who practice working memory exercises improved other general abilities, including attention and reading comprehension. He's going to speak to Empiricist League about his ongoing studies funded in part by the Office of Naval Research. So please welcome Chein.
All right, so I'm not going to be talking about sex, I'm sorry. And actually, before I get going, I actually want to address the lumosity question, because I think I can tell you about 2 problems I think lumosity has. One is they have so much data they don't know what to do with it. They actually have welcomed some scientists to take a look at their data. It's just there's so much of it, it's so disorganized, it's not in a fashion that we can actually do anything with it just yet. And the other problem is the last thing that they want to do is have somebody look at their data and tell you that it doesn't work. So they're really reluctant to do this. Actually, when I got started in this line of work, can you guys hear me okay? When I got started in this line of work, I actually contacted Nintendo. They were one of the first groups that they had this game called Brain Age that you can play on the DS. And I said to them, look, I could study this. I could see if it really works. You made these sweeping claims that it works. And I got this very polite letter back that said, no, thank you. Okay. So, Dan, you set that up really nicely. I think I have a lot less to talk about up here, which is great. But where I want to start is just make sure that we're talking about the same question. So the way I understand the question that we want to address tonight is, can cognitive training make you smarter? And the important thing I think we need to agree on is what we mean by smarter. Right? I could stand up here and tell you that the height of one World Trade Center is the same as the Euro Independence, 1,776 feet. Or I could teach you some clever little trick for being able to better remember people's names. And I could reasonably argue that in the last minute I've made you smarter if you didn't already know those things, right? But that's not the kind of smarter that we're all interested in. I think we're interested in the kind of smarter that your question was getting at, which is, can this make us smarter in a way that affects us in our daily lives? Can you get smarter in a way that you can better, you can remember more of the information you encounter, no matter what its form? Right? You don't just do some trick, but like all information is now more easily absorbed. Or can you be better in a way that makes you able to attend to the things you want to pay attention to and not be distracted by the things you don't want to pay attention to? Or could you get smarter in a way that makes you able to reason more accurately about difficult problems? That's the kind of smarter that I think we're after. And the question now becomes, can brain training deliver on that kind of a promise? And I've been working on this problem for about 10 years, and my honest answer, as a cognitive scientist, spent some time thinking about it, is a qualified yes. And I hope to convince you of that position, and we sort of set this up as a debate, right? So you'll hear my perspective, and hopefully I'll sway you somewhat, and then you'll hear Dr. Hambrick's perspective, and maybe he'll draw you back toward the middle, which gets me to the next point that I want to make. Oh, is that not advancing? There we go. You didn't see those things. Can I get there? Okay. So the next point I want to make is that although we've cast this as a debate, I think of actually all 3 of us as centrists in the debate. And my view just happens to lean slightly toward those of the believers, and I think Dr. Hambrick's view happens to lean slightly toward those of the non-believers. But a point I'd like to make is that nobody's got at stake in this. We're not making any money off of our views. And if the evidence came around that convinced us that this worked, I think we would all get behind it and start doing studies to figure out how to make it work better. And, oh, you still can't see that. There we go. Okay. That's where we all sit. Sorry. I'll try to pay attention to whether it's forwarding or not.
That's when I have hair.
Yeah, you look good. All right. So the bottom line is, look, we're not as far apart on this as it might make us seem in presenting it in this fashion. But that said, I'm going to present a point of view that really does favor the believer's perspective. But before I do, something that I'm pretty sure we agree about, at least Dr. Hambrick and I, is that you can't just take a collection of mentally challenging games, the way that Lumosity has done, and throw them together and tell people they can play them as frequently or as infrequently as they want to, and expect that they're going to get smarter, or at least not in the way that we care about. And that's what a lot of these commercial companies have done. Okay, so you can find this out there, and I want to be very clear that although I'm trying to be persuasive up here, I'm not telling you to go home and invest your time and your money in playing these commercially available programs. Okay? I don't think that they work. They tell you that they're based on science, and that is true. They are based on science. But to me, that's... Okay, you know ahead with this one. That's like saying that Abraham Lincoln, the vampire hunter, is based on the real life events of Abraham Lincoln. Which it is. There is some fact in here. There's just a heck of a lot of fiction. Okay, so here's my believer's perspective. I want to convince you of three things. The first thing I want to try to do is to tell you why we think cognitive training should work. So tell you a little bit about the science behind the idea. Very simple. And then I'm going to try to present to you some evidence that, at least in my view, convinces me that it already does work, that we have some favorable findings that I think are pretty compelling. And then the last thing I'm going to do is spend a little bit of time trying to tell you about why I think the skeptics are being a little bit too skeptical. All right, so why should it work? Very, very simply put, just like many functional movements of the body depend on a core system, your core muscles, right? We have good reason to believe that in the brain there are also core systems, there are core networks, they act as hubs, and these support core mental processes. And so the very simple idea is that if you can do something to improve those core mental processes, then it should translate or generalize into other abilities that we have. We call those core processes different things. We debate about them. We debate about their relationships. We debate how many there are. But here's some names we give them. We call them things like attention and cognitive control, and as Dan said, working memory. And these things are very closely related to our notions of fluid intelligence or executive function. And what I'm going to do for now is I'm going to focus, as Dan did, on working memory as a target for cognitive training. I'm going to tell you why I think we can target it and why I think it actually can make you better in some interesting ways. All right, again, you already have the lay of the land here. You know what working memory is from what Dan told you, but what you don't yet know is that finding that people have individual differences in working memory has led us into this world of psychometric research, it's called, where what we can do is we can measure in a very short amount of time, can give you about a 5-minute test, your working memory capacity. And it turns out that that ability, measured in about 5 minutes, predicts just about anything that you can think of, if it's cognitive, if it's mental. Here are some examples, and believe me, there are many, many, many more. But individual differences in how much information you can hold and how easily you can manipulate that information predicts problem solving, it predicts language comprehension, it predicts fluid intelligence the way we measure it in the laboratory. Okay, so once again, simple idea. Maybe I can find some way to target working memory. I can train it up, make it just a little bit better, and in so doing, you'll get better in a whole host of other things that your mind depends on these basic core processes for. And we also started in a very obvious place. We took the tasks that we've been using for decades to assess working memory. We kind of tricked them out, spiffy them up a little bit, and turned them into training paradigms. Okay, something you could do in a repetitive way over the course of a month to see if it made you better. Oh, there's lots of these training paradigms out there. They have some common features. The central goal is to improve the capacity of working memory. And we do this by asking you to repetitively perform some kind of mentally challenging, high-intensity working memory tasks. And they have some subtle differences, they emphasize different features, but they all basically are constructed the same way. And just to kind of give you an idea what I mean, I'm going to tell you about the style of training that we've used in my lab, which is based on a task called the complex working memory span task. And what makes these tasks unique is that they interleave a processing component, which is treated as a distraction in this task, and a storage component where you have to remember something. So in this version that I'm showing you here, the processing part, the distraction, is to look at the two objects and decide if they're really the same object, just rotated. Okay, it's called mental rotation. And then we're going to give you something to remember, in this case a position and a grid, a location. And so here's kind of what it looks like in motion. So here are two objects, and you decide are they really the same object rotated? And if you're able to do mental rotation, you would say, yeah, they actually are the same object. And now here comes another trial, same thing. Are these the same object? Well, they look awfully like each other, but they're actually mirror images of each other. They're not the same object. So if you got it right, you'd say no. And if 4 seconds have passed, now I give you your first thing to be remembered. So here's a position on the grid. Okay, now we go right back to the distraction. So here you go. Are these the same object? No, they're not. Are these the same object? Yes, they are. Here's another location. All right, now that's 2. Right, I'll tell you that over the course of training, you can get people up to about 12, and they can successfully remember all 12 of them. Okay, but here's what we ask them to do then, is then to tell us where were those locations. And if you're paying attention, if you got it right, if you're able to perform the task at this level of difficulty, you would know that these were the 2 locations that I presented to you, right? Very simple with 2. Try it with 12. It's a lot harder. But that's what happens over the course of about a month of training. And we use a very standard design. Most research that examines whether cognitive training works uses this basic approach. You get people to come to the lab, and you give them a big battery of mental tasks. And those mental tasks, some of them are what we call near transfer measures. They're measures of something that's a lot like what they did during training, just not quite the same thing. And then other tasks, what we call far transfer measures, are measures of more disparate cognitive abilities, things like measures of fluid intelligence or reading skill. And then we assign them into one of two groups, at least one of two groups. So one group is a group that we call a control group, where they either do nothing at all, or they do something that's an active control. They do something, but it's something that we think isn't going to improve their abilities. Or we put them into our working memory training group. And the working memory training group does this kind of, that task that I just gave you, or something like it. They do it for about a month, 40 minutes a day, 5 days a week. So it's about 20 hours of their total time if you add it all up. Okay, and then they come back in and they have a post-test, and the post-test is just like the pre-test, except it's not the exact same items. It's like different items, same measures. Everybody's clear on it? Good. So do we get better with training? The answer is yes, we do, and that's kind of a no-brainer because we pretty much get better at anything that we practice, right? Anything that you do, you're going to get better at it if you practice. That's what I'm showing you here. That's not really that important. The real important question is, does it transfer? Does it make you better at something else? And so we've looked at the near transfer measures. That is, do you get better at other things that are kind of like what you were training on? And in our hands and in many other people's hands, the answer is yes. Those who are in the working memory training condition, but not those in the control condition, show that kind of improvement. And since we mentioned it, we're going to tell you whether shocking your brain helps you. I'll tell you about our own results with that. So we have taken people and we put them into this is TDCS that Dan was talking about here. You get a little electrical shock. We give it to you for about 5 minutes, and then we do the training for about 15 minutes after that. And what we have recently found is that, in fact, if you charge up people's brains right before they go through the training, it actually leads to increases in the size of their near transfer performance. That's what's being shown here. So kind of tantalizing findings, similar to the things that you were describing. All right, but here's the real question, is does it lead to far transfer? Does it make you smarter, right? So in our own work, we have found, as I think Dan mentioned before, that in fact it does. So we found transfer to two kinds of measures. Not everything that we measured. We measured fluid intelligence, and our subjects actually didn't get better at measures of fluid intelligence. But they did get better at measures of attention control and measures of reading skill. And I want to make it clear, these are college kids. They should be already pretty good at reading. We're just making them better at reading. I'm not so sure about their attention span. That's debatable. And this finding is by no means alone in the literature. In fact, there's been demonstrations of far transfer to a number of other skills. You can read them off for yourself here, but I'll give you a couple, right? Like long-term memory improvement, impulse regulation, and this one in the bottom corner, that's the real controversial finding. Do people improve in their nonverbal fluid intelligence? But there have been a number of studies, I think you said 22, my count's 25, I think, right now, that shows successful transfer to fluid intelligence. Okay. So hopefully I've begun to persuade you that this can work, but I want to address the three skeptics' claims, the critiques of the literature, the way that I think that they're usually given, and they're as follows. Okay, one argument they receive from the skeptics is that there's a failure to replicate the findings, that there were a few early findings, but nobody can get them to repeat. I'll address that. Okay, the second one is that this might just be a placebo effect. Maybe there's something about the quality of the control groups. They just don't believe in it. The trainees believe they're going to get better, and so it works just like a placebo pill. You get better because you think you're going to get better. And the third issue, very quickly, that I'll address is the possibility that there's publication bias. That we only want to publish exciting, new, positive results. So anybody who fails to find something just can't get their work published. All right, let's start with the first one. This question about, do results replicate? All right, so again, the skeptics want you to think there were a few early findings, nobody can repeat them. Okay, and in a few slides, I'm going to tell you about why I think it's quite likely, or why there's a very straightforward explanation for why some results don't repeat themselves. And it's a statistical explanation, but I'll keep it really simple. But before I do, and more to the point, I'd like to tell you that I don't think it's true that the findings don't repeat themselves. And in fact, many of us have gone back to our original work, rerun those studies, sometimes with improved methods, and found more or less the same thing again. And I say more or less because I think that might be an important part of Dr. Hambrick's arguments as well. So just in our hands, we went back, we reran the same study that I showed you before. This time around, we did it with a control group who completed some spatial intelligence training stuff that wasn't working memory training. We didn't think it would transfer to the same skills. And we once again found that they got better at attention control. And this time we did it not just with one measure, but with two to show that it wasn't just some kind of a fluke associated with the task. So those are the results there. Okay, there's a better way to summarize whether this replicates over the literature. We can take those 90 plus studies that Dan mentioned before, and we can look for the average size of the effect. As how much improvement do you see in these individuals on average? And we can do this in a technical way called effect size meta-analysis. And I can compare improvements in the groups who trained to the groups who are in our control conditions. Okay, and a very obvious finding from this kind of a meta-analysis, here's the result, 90 studies summarized here. The average effect, shown in red, is the major advantage that you see for those who are in the training groups compared to the gray bars, those who are in the control group. And we can split this up because this combines near and far transfer findings, but I can split it and I can show you that in fact both near transfer and far transfer show the same pattern. People who get working memory training improve more on far transfer measures like fluid intelligence, reasoning, problem solving, attention control than the people who don't. And this is actually an important part of the finding here as well. So I'm focusing in on the far transfer findings, and I can get an average effect size estimate. You don't really need to know what the numbers are, but here they are in case you care. The average effect size is 0.36. As effect sizes go, this is pretty small. This is not a big effect, but it's a significant effect, and it's a measurable effect. And the difference from those who are in the training group to those in the control group is actually only 0.21. It's pretty small. And here's why I think it's important, is it gives us our answer to why studies don't replicate. Okay? The reason that they don't necessarily replicate is that with an effect this size, 0.36, and a typical study with 37 participants in it, we only have a 30% shot of seeing it. If it's a real phenomenon of that size, we're only going to find it 30% of the time. And then on the flip side of that, we have to run much larger studies than the studies that we tend to run. We have to have more than 200 subjects in them to have an 80% chance of seeing that real effect. So why did somebody find it once but then not again? Because they have a less than 50% shot of repeating it, even if it's a real phenomenon. That's my 15 minutes? Okay, good. Okay, placebo effect. Here's the basic idea, right? Maybe those who are in the working memory training condition just believe they're going to improve. They expect to improve because they're somehow handheld, or they think, all right, this is it. I get it, right? You train me in working memory, and I'm supposed to get better at it. And those in the control groups, they just don't believe they're going to improve because they did nothing or they did something that was implausible. That's the idea here. That's the skeptic's concern. So let me address it directly. I'm going to show you first from my own work, so two studies that I think address this question about the placebo effect. The first is a study we did in older adults. So these were 65-plussers. So some of you think of that as older, some of you may not. Okay, they were seniors anyway. And we gave them two types of training. The working memory training group, the ones that we thought would get better, was our main active group. And then we also gave another group trivia training. Okay, so they just did trivia every day. And here was the interesting thing in this group. They're very, very motivated. They all want to get better. And those who were in the working memory training condition, they hated it. They didn't think it worked, they thought it was boring and repetitive. They didn't think it would have any impact at all. The people in the trivia training group loved it. And they were sure that they were going to get better. They told us all the time, oh, this is great. It's like I'm doing crossword puzzles and Sudoku, and now I get to do trivia too. And it's really helping my mind. So their expectations, the placebo effect, would favor a result for the trivia group, not the working memory training group, right? But we actually found the opposite pattern. What we expected to find, in this case, getting better is going down. These older adults were better able to stop repeating themselves about the things that they had previously remembered. It's a little bit more sophisticated than that, but that's the basic idea. All right, now on the flip side of that, we did another study, this time with video game training. And we had people explicitly tell us, how motivated are you? How engaged are you? And how good do you think this has made you at some task that we're going to measure? So here's their motivation and engagement scores, and what you can see is they were the same. This is a group of people who played an action video game and a strategic video game that had different impacts on cognition. Same motivation, same engagement. And then we asked them, well, how good do you think this made you at the subsequent measure? Okay, so here's their estimate of how good they thought they had gotten, or how much they thought they had improved. And you see it's the same. But nevertheless, our active training group improved significantly more than did the control training group. And here's the point I'm making. Expectations are neither necessary nor sufficient to produce an effect of the kind that we see. Okay, now if that doesn't address the question directly, here's another way to address it. So here's the results I showed you already before, the meta-analysis. Training, you see larger improvements than control. But inside that gray bar, it actually collapsed two different kinds of control groups. The people who came in and did some alternative activity that they thought would probably help, like trivia. We can call them active control groups. And then there were others who were passive control groups, or no contact controls. They came in, they took a test, they went home, did nothing related to the study, and then a month later they came back. And if there's some kind of an expectation or placebo bias, then what we would expect is that the active controls should show increased improvement relative to the passive controls. And we can look at that. So when I split them apart, 90 studies, about 30 in each, just the way it worked out, you see no difference at all. Completely the same result, whether they expected to improve on the basis of their activities or not. Okay, and then really quickly, let me just tell you about why I don't think publication bias is the answer either. So the first is that actually publishing in this area of work was pretty hard. And that's because the conventional wisdom in the field of cognitive psychology is that you only get better at the things that you train in and nothing else. So when we went to publish this work, nobody was that receptive, even though it was a positive finding, and that was true for a number of the people in the early days of the field. It's probably a little bit better now. The other is that perhaps more so than any other area of work in cognitive psychology, this is an area of work where the top journals are encouraging people to publish their null or non-findings. So that's my second point. And there are actually a number of null results that are now successfully published. So we're kind of getting, it doesn't look like there's just a sampling bias or a publication bias in the literature. Okay, and the third, and this is a quick point, is that publication bias has a telltale sign, and that's positive skew. Here's what it looks like. If there's no bias at all, then the effect sizes should distribute normally around the mean. Everybody who studies it should kind of find about the same thing on both sides of that average. But if there is a publication bias, then you see what's called a positive skew, where the studies are always more favorable, but on the other side, the weaker results, nobody publishes them because there's a bias. They can't get them published. And just to really quickly show you what the data from FAR transfer look like, they line up almost perfectly onto a normal curve. There is no publication bias indicated in this skew. Okay, so to quickly summarize on the end of my time here, I would argue that core abilities can indeed be trained, that we've actually shown that that we've successfully demonstrated that there is evidence of that. And I think concerns about replication, about placebo effects, and about publication bias are potentially overblown or a little bit misleading. And in my view, I think the real work is just getting going. So thank you.
Yes, you talked about outside stimulation. You showed that electrical thing on that person. You said that improved. I think you said it improved somewhat their intelligence. Have you ever done studies or included the studies of people who've been in accidents and they wake up from their coma or their accident and suddenly they can play. They never looked at a piano in their life, so they sit down. They can play Beethoven's Fifth by heart and whatever. You know, they like virtuosos.
Yeah, I mean, no, I haven't done work on them. There are such cases. I'm very familiar with the phenomenon. It's amazing what the brain is capable of doing sometimes when it's broken, and sometimes it just seems to rewire itself for certain activities, but it's a phenomenon that happens so rarely, it's very difficult to study it in any systematic way. Okay.
Hi, I'm going to ask you the question I was going to ask the previous speaker. It was actually even more relevant to your presentation. Before I do, one sentence, not a question. Today's Wall Street Journal, personal journal, has an article called Electric Boost to the Brain. The researcher tries mild jolts to improve math performance. Surprising results. Just thought I'd mention it. There used to be a game show on TV, not a crooked one and not a stupid one, called Concentration. I don't know how many here will remember it or if you know of it. I guess you don't.
I don't.
It was a grid of maybe 5 by 5, something like that. And you'd indicate 2 boxes that you want turned over. And there would be like a product on it, maybe like a stone or a car or whatever. And usually they would match, the odds are. And then another 2 would be turned over, and another 2, and the point was you'd win whatever you could remember where the 2 things were.
I remember the game. It had a picture behind it, right?
Yes,
so you'd reveal
yes.
the picture and you'd guess the picture.
Pretty
Yeah,
much
the memory game.
Because that sound, isn't there something of what you're talking about in that? Because it did involve not remembering what was sometimes displayed 1 turn ago and sometimes 6 turns ago.
Right. I think I'll take you back to the last point that I made, which is we're just getting going. And one of the real problems here is we don't know what makes something work and what makes it not work. And so activities like that, they may work, but we need to study them systematically. And the problem is sometimes things that we think might work don't end up working. And we're not sure if they're not working because our statistical power isn't adequate to see the effect, or if they're not working because there's something really important about what we've done that makes it not work. And so I don't have an answer directly. Those are like the games that we have people play, but they're sometimes they work, sometimes they don't. And figuring out what the invariant property is what we're trying to do. Yeah?
Do the effects last if the training stops?
Okay, that's a great question. The question is, does the effect last if the training stops? Nobody knows the answer because nobody's bothered to do those studies. What we have done in a few studies is come back about 3 months later, or 4 months later, or up to 6 months later, and you can sometimes, not every study, but some of them will show some longevity. What nobody's done is compared some kind of like booster shot of training to doing nothing at all in between and seeing whether that makes any bit of difference at all.
Can I ask a follow-up? And does physical condition have anything to do with anything?
Okay, I don't know the answer. I mean, what I do know is that there are people who are now looking at whether combining physical components with mental components enhances the mental gain, sort of the way that the TDCS work that I described does, but I don't know if physical condition matters ahead of time. I'll take a question back here.
Two-part question. One, so you said that the commercial solutions don't work. Is there anything that does work? And then two, does any of this relate to EQ?
Okay, so I'll take the first part of the question and say, I'm only telling you that I'm not suggesting that you go use the commercial programs. Whether they work or not remains to be demonstrated. I don't think anybody's analyzed the data. So they're claiming that it works because they want you to buy their product. We don't know. It might work. It might not. Is there anything that works? I think I'm trying to show you that I think that some very systematically and carefully administered programs do work. They work to a limited extent, and what it means for them to work is something that we might want to debate. But they do make you smarter in the sense that they improve attention control, they improve reading comprehension, and so on. Yeah, and then the second question is related to emotional IQ. The answer is nobody has checked that out at all. We're actually running a study now, though, where we're looking at whether a form of training that involves an emotional component makes you even better able to deal with certain emotional arousal, conflicting information that comes from emotional arousal. 2 more time. Okay, 2 more. I'll take this question over here.
So all these studies are very analytical in nature, having to do with memory, recall, and sort of cognitive abilities. Have there been studies on how this kind of brain exercise affects creativity or artistic output?
Yeah. Okay. So the question is have these studies ever looked at outcomes for creative ability or artistic output? There are a few measures that people have related to creativity that have been included in these studies. And to my knowledge, I can't off the top of my head think of one that showed successful transfer to those measures. But again, that's actually an area that people have taken interest in recently. The one exception to the rule is mindfulness meditation training. And there's one study demonstrating improvements in a measure that it's a cognitive flexibility, which people think is a measure of creativity. Yeah, but it's a great question. I think it's a kind of low-hanging fruit for people to do work on. Okay, and then right here.
So it's kind of a similar issue. Right now, in the field of education, it seems that they've sort of divided the definitions of intelligence. For example, for college acceptance right now, the ACT versus the SAT are considered equal measures. The common thinking is that one has to do with how much you remember, that would be the ACT, versus your problem-solving capability with unknown variables, which is the SAT. The Common Core standards, which are now, the federal rule and 45 states have adopted them, have to do mostly with process skills rather than content memory, right? So a lot of the studies that both speakers have alluded to have had to do with working memory and actually that idea of what you remember rather than what you do when you encounter unknown variables. So I guess I'm wondering, can you comment on that?
Yeah, okay. So this one gets a little bit tricky because it gets into the difficulty that researchers have in agreeing on what working memory really measures and what it refers to. The sort of simplistic way to describe it and the simplistic way to think about it as a holding space in the mind. But I think what actually probably Dr. Hamburg and I agree about is what working memory is really about is the ability to control the focus of attention, to determine what information stays in mind, what information doesn't get into mind in the first place, and actually using internal attention to retrieve information from the past to make it available to you in the immediate present. And because of that, it actually relates more closely to processing than it does to kind of like just having enough knowledge or information at your disposal to answer some of those questions. I don't know if I exactly answered the question you're asking, but I think it's about how you conceptualize working memory. Yeah.